Harbinger gave an equation. In order to understand orbital, he gave an equation, quadratic equation with the Cartesian coordinates x and y, z, del square x by del x square, del square y by del y square, plus del square psi by del z square, plus 8 pi square m by x square into E minus V is equal to 0. E is the total energy, V is the potential energy, m is the mass of the electron. All of you know x is the Planck's constant, all of you. This equation, quadratic equation, when we solve, we got many values because you know quadratic equation is to give many answers. When we see the psi, that psi is nothing but the amplitude of the curve, amplitude of the wave, which is called wave function. This amplitude, it comes in the plus value as well as in the minus value. So we couldn't come to conclusion with the psi value. When we square it, we get some meaning, significance. Psi has no significance. Psi square has significance. It is named as orbital. What is orbital? For example, you are having house. Inside the house, you will be having so many rooms. This school, it is a school. Here we are having so many classrooms. These classrooms are like orbitals. Our school is the orbit. So it depends upon small school, big school. Small school will have limited number of rooms. Big school like us will have many number of rooms we are having. So it depends upon the orbit, number of the orbitals may differ. That we are going to see next. Orbital, sub-energy level, it is a maximum probability of finding electron density around the place in space. For example, hydrogen. It is a cation. It is nucleus. Hydrogen is having only one electron. Can you tell me where is the electron in this orbit? Here or here or here? What is the maximum probability? So scientists search that electron in terms of radial coordinate and angular coordinate. Angular coordinate will involve theta and phi. That is called angular. This way also angular way you can search. If you are searching in picometer from the nucleus, that is called radial coordinates. In angular way, then if you search like this, then it is called theta. So angular coordinates will involve angle on the plane and in space also. Put together theta and phi and radial coordinate. When you search, you will find out where the electron density is maximum. That place is only called orbitals. That is only called orbitals. When you see, there are 4 types of orbitals which we are going to learn in our syllabus. One is called S orbital. There is S orbital. When you see, it will be spherical in nature. That is why it is called S. The electron density, if you see, electron is not like a chalk piece. It is a cloud, charged cloud. It will be moving in the form of a spherical way. So it is S orbital is spherical in nature. When you go to P orbital, next one is P orbital. It will be having, this shape is called dumbbell shape. Depends upon the axis. It is axial oriented, direction oriented. If I draw like this, then it is called, it is along the x-axis, the electron density is more here and more there in the lobes. Then it is called Px. If it is like this, means it is called Py. If it is going to be in the z-axis, or if you are having this is your z-axis, then it is called Pz. So P orbital is 3-directional oriented, x, y, z. If you come to the d orbitals are 5 way it is oriented. One is dxy, dyz, dzx, dx square minus y square, dz square. So first S orbital I said it is not directionally oriented. P orbital is directionally oriented, px, py, pz. D orbital, third orbital is d orbital. Fourth one is f orbital. So dxy, dyz, dzx, dx square minus y square, dz square. All the d orbitals I am going to draw. These 3, they will come in between the axis. Now I am going to draw dxy and dxy. See here, this is y axis means then it is called, so electron density is spreading like that. The y is at how will you draw? It is also in between the axis. Same manner you will draw, but you will represent the axis as y and z. How will you represent the z and x? It is also in between the axis. So how will you draw? It is x axis, it is z axis. How will we draw that? X square minus y square. We are going to draw the x square minus y square. They are not coming in between the axis. It is going to come along the axis. So I am going to draw. It is along the axis it is coming. X axis, y axis, dx square minus y square. How we are going to draw the dz square? It is only one number and one ring. Electron density is present. Like Saturn, you might have seen. Planet Saturn used to draw like that only. It is Z. So are you all clear? All the 5 d orbitals, they will ask you to draw the boundary, electron boundary diagram of all the 3 orbitals which are in our course. S orbital, p orbital, d orbital. If you want, I will draw again p orbital separately. P orbital, this S orbital, px, py, pz. Px means it will come along the x axis. Py, it comes along the y axis. Z, this is Z. You have to write it is Z axis. Then only it is correct. Z axis. Now we have understood what are the orbitals. They are the probability of finding electron density around the nucleus in space is called orbitals. Now we are going to see quantum number. These are the numbers, set of 4 numbers which tells about the characters of electron, which is n, l, ml, ms. N is called principal quantum number. L is called azimuthal quantum number, or it is called subsidiary quantum number. Third one is called magnetic quantum number. It is otherwise called orientation quantum number. Last quantum number is ms, is spin quantum number. First one, principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. Hope all of you able to draw all the orbitals. So now we are going to see how these 4 orbitals will tell about the character of an electron. Hydrogen you are having. It is having only 1 electron. How to identify the character of the 1 electron of hydrogen? How it will differ from the helium which is having 2 electrons? Now let us see. N. This N value tells about the size. N value is equal to 1, 2, 3, 4 like this. It goes on up to infinity. K is equal to 1 means it is K shell, L shell, M shell, N shell. Like this it goes on. So from that we can understand which is larger in size, K shell or M shell? K, L, M. So which will be bigger in size? M is bigger compared to K. So it tells about the size. N value tells about the size. It tells about the radius. Already we have studied the formula for radius. 52.9 into Z by N square into N square by Z. 52.9 into N square by Z. So N value increases, radius of the orbit also will increase, radius will increase. Then energy. For energy in the previous slide only we have seen energy formula. There also we have, for each orbit, what is the energy level? First orbit, minus 1.312 into 10 power 6. You want to write, you can write 10 power 6, or you can write, remove this and you can write 10 power 3 also. Joule per mole by N squared. So this N squared is there in the energy of the orbit also. I want, what is the energy of the 5th orbit in mole? In joule per mole you calculate for hydrogen and helium. So 5th orbit means what will you put? 5 square. 4th orbit means what will you put? 4 square. 3rd orbit 3 square. So energy of any orbit will be given by this formula. So what are the points we can understand from the principal quantum number? Yes, energy, radius and size of the orbit can be understood with the principal quantum number. There is no formula to calculate the n value. It automatically goes from 1 to infinity. N can be never equal to 0. You have to understand. Next one, L. Azimuthal quantum number. Azimuthal quantum number. It is also called subsidiary quantum number. Its value is 0 to n minus 1. ML, what is its value? Its value will be minus L to plus L. If you know this, you can calculate this. If you know this, you can calculate ML. If you know ML, you can calculate MS. MS means, MS will not have a formula related with that. It is always having minus of or plus of. That is, electron will either spin half in the positive direction or anti-clockwise direction or in the clockwise direction. So it will be plus of or minus of, constant value. Only these three quantum numbers will change. Let us make out the chart by using n value, L value, then L, ML value. If n is equal to 1, what will be the L value? Substitute the formula 0 to, it is 1, n value is 1, 1 minus 1 is 0. If it is L is equal to 0, it will always represent, L is equal to 0 will represent S orbital. Orbital. L is equal to 1 means it will represent P orbital. When L is equal to 2, it will represent D orbital. When L is equal to 3, it will represent F orbital. We have not seen much about F orbital. We have seen only S orbital, P orbital, D orbital only we have seen. If it is L is equal to 0, ML value. See the ML formula, minus L to plus L. 0 value, L value is 0 means, is there any minus 0 plus 0? No. So there is no value for ML. Now let us assume it is 2. If it is 2, N value is 2 means, its formula is 0 to n minus 1. 0 to n minus 1 means 0 will come, n value is 2, 2 minus 1 is 1. So 0 also will come, 1 also will come. So second orbit, it is K shell. K shell will have only S orbital, that is 1s orbital. Orbital it will have is only 1s. Now come to the second shell, L shell. L shell will have S orbital as well as P orbital, because L is equal to 1 means I have written P orbital. So here what are the values will come? When L is equal to 0, we will not have minus 0 to plus 0. When L is equal to 1, minus 1 to plus 1, minus 1, 0 plus 1. ML value will be minus 1, 0 plus 1. So it is 0 means it is S orbital. So it will come to 2s orbital. This is 2p, this is p orbital means it will become 2p. In the 2p, you know, I have written 3p orbital. Px, py, pz. That is only this. Px, py, pz. The 0 denotes the pz orbital. If it denotes px, this will denote the py. If it denotes py means that will denote the px. That's all. But 0 value always denotes the pz value. Now come to the 3. N is equal to 3. What are the values will come? 0 to 3 minus 1. 0, 1, 2. 3 values will come. Then it will be 0 means it is 3s orbital. 3s orbital. It is 0. ML value will be 0. 1 minus 1 plus 1. 0. 2 means minus 2 to plus 2. Minus 2 to plus 2 means what will come? Minus 2 minus 1, 0 plus 1 plus 2. So this corresponds 3s orbital. This one value corresponds 3p value. 3p it will have 3 values. Minus 1 plus 1, 0. It is 2. Then L is equal to 3, L is equal to 2. Then it will denote D orbital. D, how many D orbitals is coming? 5 D orbitals. What are they? dxy, dyz, dzx, dx square minus y square, dz square. So likewise you can take it for 4. 4 when you are writing, F orbital also will come. Then it will be 3. Then it will come minus 3 to plus 3 it will come. That is 7 orbitals. F has 7 orbitals. Those 7 orbitals will come. This spin quantum number already I told. It can be minus of or plus of. In the next video we will see all the principles and laws that is related with all these quantum numbers we will see. Thank you.